Hey guys, welcome to Safi Mixed. In this video, I will drive a very important formula that will enable you to find the eigenvalue of a 2 cross 2 square matrix. That is the formula that I'm going to derive is applicable to any 2 by 2 square matrix. To this end, let me write a square matrix in the form A equals A, B, C, and D. And I want to construct a formula that could give us the eigenvalue of such a 2 by 2 square matrix. In order to find the eigenvalues, we follow the procedure of eigenvalue equation. That is, I need to construct a matrix like this. And that matrix then leads to A minus lambda D, C, and B minus lambda. I have two other videos on the characteristic of eigenvalue equation. So if you are interested in, you can watch those videos whose link I'll add to the description of this video. But in order to solve the eigenvalue equation, we always construct this matrix in the form of this. And now there is a condition on this matrix that the inverse of this matrix is not existing. And if the inverse of this matrix is not existing, then we can take the determinant of this matrix equal to 0. And that is, we write determinant of A minus lambda D, C, and B minus lambda equals 0. If this condition is true, only then we can solve the eigenvalue equation. So I can find the determinant of this, which is in fact A minus lambda times B minus lambda. That is, I multiplied the diagonal terms and then minus the off diagonal terms, and I'll set this equal to 0. I can put this equation into another very useful form. That is, if I remove the parentheses, I can remove A times B minus A times lambda minus B times lambda, and then plus lambda squared minus CD equals 0. Let me rearrange this equation in the form lambda squared minus, I can take minus common from these two terms and can write them in the form A plus B times lambda, and I can write these two terms together to write them as AB minus CD equals 0. Okay, now there are the coefficient of lambda and this constant term. This is in fact a quadratic equation in lambda, and this thing, if we look, is equal to the trace of matrix A. That is, we know that the trace of A is the sum of the diagonal terms, so the trace of A is in fact A plus B. And similarly, the determinant of A is the product of the diagonal terms minus the product of off diagonal terms. That is, determinant of matrix A is equal to A times B minus C times D. And if I look into this one equation, this thing is exactly equal to the trace of A, and this thing is exactly equal to the determinant of A. That means I can put this equation into this form. Lambda squared minus trace of A times lambda plus determinant of A equals 0. So this is a quadratic equation, and the roots of these equations are given by lambda equals minus B. So it will become plus, so I write this trace of A plus minus square root B squared. This corresponds to B, so I write this as trace of A squared, The square of minus will become plus, so I'm not writing that. And then I will write minus 4. The coefficient of lambda square is 1 times this constant, so 4 times determinant of A, and the whole divided by 2. That means for the square matrix, we have two eigenvalues. One corresponds to the plus sign and the other corresponds to the minus sign. So if you know about the matrix, using this one formula, you can find the eigenvalues from the trace of the matrix and from the determinant of the matrix. And this is very important, so you should memorize this. That is, if you know about this formula, if you could memorize this formula, you can find the two eigenvalues of any 2 cross 2 square matrix. Now I want to find two other very important properties of the eigenvalues of the square matrix, and for that I want to write this equation in the form of lambda 1 equals trace of A plus square root trace of A whole squared minus 4 determinant of A, the whole divided by 2, and lambda 2 equals trace of A. Now I'm writing the negative sign minus trace of A whole square minus 4 determinant of A divided by 2. Now if I add these two equations, I get this thing. Lambda 1 plus lambda 2 equals trace of A divided by 2 plus trace of A divided by 2, and this term is exactly the negative of this term, and this term cancels exactly with this term, so we get trace of A divided by 2 plus trace of A divided by 2, which in fact is equal to trace of A. That is, the sum of the two eigenvalues of a square matrix is exactly equal to the trace of A. And this property is not only true for a 2 cross 2 matrix, rather this is true for any square matrix of any order. So the sum of eigenvalues of a matrix is always equal to the trace of A. I call this equation 1. Now I multiply these two equations with each other, and for that I want to write them from here. Multiplying these two equations with each other means I'm multiplying lambda 1 with lambda 2, and that would allow me to write trace of A plus square root trace of A squared minus 4 determinant of A, the whole divided by 2, and again multiplied with the same thing but a negative sign over here, that is this thing. So I write trace of A minus square root trace of A squared minus 4 determinant of A, the whole divided by 2. Okay, now this is something like A plus B multiplied with A minus B. So I can write the trace of A squared as a result, and the 2 with 2 would make it 1 by 4, so I write that over here, and that would give me trace of A squared minus this whole thing, to that equal to trace of A squared minus 4 determinant of A. Now this trace of A squared cancels with this trace of A squared. This will become plus because A squared minus B squared, so that minus multiplied with this would make it plus. And no. A squared minus B squared. Will this be positive a squared minus b squared? So that minus multiplied with this one is a plus b. Yes, this would be plus and this one would be minus. That's true. Now, the 4 cancels with this one and we are left with determinant of A. That is, the product of the two eigenvalues of a square matrix equals the determinant of A. I call this equation 2. So equation 1, the sum of eigenvalues equal the trace of A, the product of eigenvalues equal determinant of the matrix A. Now we have two equations. If we know about these two equations, if we know about the matrix, we can find the trace of A to put that over here, and then we can find the determinant of A to put that value over here, and then we can solve equation 2 and equation 1 to find the eigenvalues. So this is another way of finding the eigenvalues of a 2 cross 2 matrix. That is, set the sum of the eigenvalues to trace of A, the product of the eigenvalues to determinant of A, and then solve the two equations for lambda 1 and lambda 2. This way you can get the eigenvalues of a 2 by 2 square matrix. And thanks for watching.